Hey guys, it's Max. I'm going to teach you guys about developmental pathways today. So we got a pathway set out here which leads to the formation of spikes in certain cells of the ectoderm of this guy right here, the spiny beetle. So the few things I want to talk about. First of all, the letters here are genes. All these genes can be detrimental in the formation of those spiky cells. And a gene can either do one of two things. They can either stimulate transcription or inhibit transcription. So these arrows here, they're going to indicate that the product of a gene is stimulating the transcription of another gene. And these guys right here are known as T-bars, and they indicate that the product of a gene is inhibiting transcription of another gene. So the S gene is going to stimulate P, P stimulates I inhibits K inhibits E, and E stimulates production of spikes. So if this is working correctly, then I is going to completely inhibit K, so no K will get produced, and so E isn't inhibited, and then you get a spiky cell. But mutations happen, and we're going to talk about a few of them and how they affect the pathway. So mutation is denoted by a little minus sign here. So in this first case, we have a scenario where P is mutated. So if P is mutated, then that means it is not doing its job correctly. So it cannot stimulate the transcription of I, so there's no I in this pathway. And so that means that K is no longer being inhibited, so it can get made freely. And if it's made freely, it can inhibit E. And if there's no E, then we don't get spikes, we get a smooth cell. So if, let's say it happens if just I is mutated. Well, if I is mutated, we get the same kind of deal. K is being made freely because it's no longer being inhibited, so it can inhibit E and lead to smooth cells, those spiky cells once again. So what happens if I and E are both mutated? Well, if I is mutated, we already know what happens then. We get a smooth cell because it's no longer inhibiting K. But even if it was working, we would still get a smooth cell because E also is not working. E is mutated and unable to do its job. It wouldn't be able to produce those spikes. So we get a smooth cell regardless. And so our last mutation is what happens if S and K are mutated. So if S is mutated, we no longer can produce P, we can't produce I, and because K is also mutated, K can't do its job either, so it can't inhibit E. And so none of these genes, stimulate the transcription of E. E is still being made regardless of what happens with these guys. This is no longer being inhibited either, so it can keep producing spikes. So in this case, we would get spikes, spiky cells. So DNA tends to mutate a lot, and just because of how many cells, how many bases are involved, and it's not always noticed and repaired correctly. Some of it is, some of it isn't. And in this case, in this pathway, 4 out of 5 of these genes, if they're mutated and don't work, will lead to a smooth cell. That's the biggest reason why not all of the cells in the ectoderm of the spiny beetle are spiky. Some of them are going to be smooth just because of how easily mutations can happen and how easily they can affect this pathway here and cause a smooth cell. So that's developmental pathways. Thank you.